All right, for this equation, they're asking us to solve it just on the interval 0 to 2 pi, so that means at the end we won't have to add those rotations. So I have a tangent 2x and a tangent. In order to combine those, I need to get that out of a double angle and use my double angle formula. So tangent of 2x, that's going to turn into 2 tangent x over 1 minus tangent squared x plus tangent x. Okay, so if I'm trying to solve that equal to 0, I want to get this tangent x piece into a fraction like this one. So I'm going to multiply top and bottom by 1 minus tangent squared, which means my fraction now, I have 2 tangent x's plus tangent x times 1 is just tangent x. Tangent x times negative tangent squared x is negative tangent cubed x. Okay, what do we have on top? Well, we have tangent x plus tangent x, that's equal to 0, sorry. Tangent x plus tangent x, now I have 3 tangent x's minus tangent cubed x, which both of those terms have tangents in them, which I could have done that all in one line, but it's okay, we can do another line. So both of those have tangents in them, which means I can take a tangent out. So I'm going to have tangent x times 3 minus tangent squared x. Okay, so this is now factored as far as I can go. Technically, I can factor this one step further, but it gets gross with radicals in there. So I'm going to just set these separately equal to 0. The first one says that tan x equals 0. The second one says that tan squared x equals 3. This one tells me where is tangent equal to 0. It's equal to 0 when sine is equal to 0, which means it's at 0 and pi. And how often does tangent repeat itself? Tangent repeats itself every pi, which means that I don't actually have to write both of these. I can just write 0 plus pi in. That's going to hit the pi, it's going to hit the 2 pi, the 3 pi, all of them. I don't have to list them separately because I'll just be repeating myself. All right, what about tangent squared x equals 3? That is when, let's see, tangent x equals plus or minus the square root of 3. Okay, tangent is square root of 3 when sine is square root of 3 over something, which happens at our pi over 3 angles. So this is going to be all of our pi over 3 angles. It's pi over 3, 2 pi over 3, 4 pi over 3, blah, blah, blah. But again, remember, tangent repeats itself every pi, which means that pi over 3 plus pi is going to catch the 4 pi over 3. 2 pi over 3 plus pi is going to catch the 5 pi over 3. So I don't have to write all 4 of them. I'm just going to write a plus pi in on both of these, and it will catch those other 2 that I didn't list. So all of my answers here on, oh man. So all of my answers here, if I were looking for all possible solutions, would be the ones that I have listed. Now let's go back. I did more work than I had to. All they asked for was on 0 to 2 pi. Which means I don't need to do all this repetition stuff. I'm just going to list them all out. So what do I have? I have 0 and pi. I have pi over 3, 2 pi over 3, 3 pi over 3. Wait, no, we already got that. 4 pi over 3, 5 pi over 3. So if they'd asked for all possible solutions not on a given interval, we would have listed them like this. Oh, I didn't even put an x equals. We would have listed them like this. But if we're just listing out the ones on that unit circle, the first loop of the unit circle, these are our answers.